Okay, we're going to quickly review what slope is and how we're going to be using slope. Slope indicates the steepness of a line. In the last unit you found slope without knowing it. You used the common differences to determine the rate of change in a problem. Rate of change and slope are really the same thing. Today we will learn to find slope by finding the difference in the rise and dividing by the difference in the run. Okay, to determine slope, you need to remember that slope is always defined as change in y over the change in x. Or you can use the slope formula, which is what we will start out with today. The slope formula is m equals y2 minus y1 over x2 minus x1. And when we look at our first example, which is 1, 3, and 4, 5, 1, 3 is the first ordered pair and 4, 5 is the second ordered pair. And then we just use the slope formula to determine the slope of a line with those 2 points in it. So y2 is 5 minus y1, which is 3. And all of that is divided by x2, which is 4, minus x1, which is 1. And we end up with 5 minus 3 is 2. 4 minus 1 is 3. So our slope is 2/3. Okay, we can do the same thing with our second example. Our second example is a little bit more challenging because it has negative numbers in it, so we have to be careful when we set this up. y2 is 1 minus y1, which is negative 2. All of that is over negative 4 minus negative 1. Be very careful with your integers. I have 1 minus a negative 2, which with the leave change rule becomes 1 plus positive 2, or 3. And then I have negative 4 minus a negative 1, which becomes negative 4 plus a positive 1, which gives me negative 3. And I end up with m equals negative 1. Okay, for the third example, you can pick any 2 points and use the slope formula. Okay, so I'm going to pick these first 2 points. So y2 minus y1 over x2 minus x1. Okay, negative 4 minus a negative 7 becomes negative 4 plus positive 7, which equals 3. And 7 minus 5 is 2. So my slope is m equals 3 halves, or 3 over 2. Okay, it doesn't matter which points you pick. Any points on a line will have the same relationship, so you will get the same slope with any 2 points. Okay, the second way that we need to be able to determine slope is from a graph. Now for our first example, we have 2 ordered pairs. The first one is negative 2, negative 2, and the second one is 1, 0. Okay, I can use the slope formula again. M equals 0 minus a negative 2 over 1 minus a negative 2. 0 minus negative 2 gives me 2, and 1 minus a negative 2 gives me 3, so I have a slope of 2/3.
Mrs. Beabout, you have a call on 79, Mrs. Beabout.
So I can look at this graph and find the slope by counting the rise over the run. So if I look at this first example, I start with my first point towards the left because we read at the graph from left to right. And the rise is 2 and the run is 3. So I end up with the same answer whether I count the rise over the run or whether I use the slope formula. Okay? For my second example, let's count the rise over the run. Now this one, if we start with the first point to the left, my rise is going to be negative because it's going down. It goes down 4, so it's negative 4, and over 1. So the rise over the run is negative 4 over 1, which leaves me a slope of negative 4. Okay? The last example, again, I will start with my point that's furthest to the left, and I will count the rise, which looks to be 1, 2, 3, 4, and the run, which is 1, 2, 3, 4, 5. So my slope is 4/5. Okay? The last thing that we need to be able to do is, by looking at a graph, determine what type of slope we have. It's very easy to find out whether you have a positive or negative slope. Again, you would count the rise over the run, and in this case it's 3 over 4, and that's positive, so we have a positive slope. Okay? On the second example, we would count the rise over the run, and it is negative 3 over 4, so we have a negative slope. Okay, and again, another way to look at it, our first example, if you look at it from left to right, it's increasing, or my arrow, my line is going uphill. Okay, that's whenever you have an increasing graph, you have a positive slope. The second graph, it's decreasing from left to right. When you have a decreasing graph, you have a negative slope. The third example shows no slope, or 0. It's not going up, it's not going down. Okay? The first 3 examples are all functions. They would all pass the vertical line test. What that means is that for each element of the domain, there is only one matching element of the range. The last example here is not a function, okay? This graph is the slope is undefined. And what this means is for the domain value of -2, there are many, many different range values. Okay, when you see a graph that is an up and down graph, you have an undefined slope, and we discussed that in class at length. So the things that you need to remember for today are how to find the slope of a graph by looking at the graph and counting the rise over the run, and how to find the slope without the graph if you're given 2 points.